When designing a pump station with an indoor generator, especially concerning the use of motorized dampers and the generator room louvers, several factors must be considered to ensure the reliability and effectiveness of the backup power system. The primary concerns revolve around potential generator failure due to damper malfunction, interlock dependency, generator overheating in winter, and condensation accumulation. Firstly, consider the generator failure due to damper malfunction. The motorized damper should be designed with appropriate reliability and redundancies to minimize the risk of failure. Consider using multiple dampers or a fail-safe design that ensures the damper opens in case of a malfunction. This redundancy is crucial to preventing a scenario where a failed damper inhibits the generator's operation during a power outage. Secondly, address the interlock dependency. The interlocking between the generator and the damper should be robust and reliable. An interlock failure could lead to the damper closing and suffocating the generator, even during a power outage. The interlock system needs to be carefully designed and regularly tested to ensure its proper function. Thirdly, be aware of generator overheating in winter. If the damper is not fully open, it can restrict the generator's air intake, leading to overheating. Ensure that the damper is designed to provide sufficient airflow for the generator's cooling requirements. Proper sizing and testing of the damper's airflow capacity are essential. Fourthly, think about condensation accumulation. With the dampers closed, moisture can accumulate in the generator room, potentially leading to corrosion or equipment damage. Consider additional ventilation measures such as a dedicated ventilation system or moisture control devices. Maintaining adequate ventilation even when the dampers are closed is important for preserving the equipment's integrity. In light of these concerns, several alternative solutions can be considered. One potential option is manually operated dampers. Manually operated dampers can be used to close the louvers during winter without the need for motorized controls. While this option requires operator intervention, it eliminates the potential for damper malfunction and interlock issues. The simplicity of manual dampers offers a reliable solution. Another option is automatic louvers. Some louvers have built-in temperature sensors that automatically adjust the louver opening based on the ambient temperature. This can help prevent freezing while still ensuring adequate airflow for the generator. Automatic louvers offer a balance between automation and reliability. Also consider a gas fireplace instead of a unit heater. A gas fireplace can provide localized heating for the generator room without requiring a damper system. A gas fireplace could be a simple way to provide heat to the unit so it is protected from the cold. To ensure the system's reliability and safety, the following recommendations should be considered. Firstly, conduct a thorough risk assessment to evaluate the potential consequences of damper malfunction. Secondly, design and procure a motorized damper with high reliability and redundancy. Thirdly, use a robust and reliable interlock system between the generator and the damper. Fourthly, consider alternative solutions such as manually operated dampers or automatic louvers to minimize the risk of generator failure due to damper malfunction. Fifthly, implement additional ventilation measures to prevent moisture accumulation if the dampers are closed for prolonged periods. These actions will help to ensure that the generator operates reliably when needed. When selecting a motorized damper, consider the following factors. The damper's construction should be robust and durable, capable of withstanding the environmental conditions in the generator room. The materials used should be resistant to corrosion and degradation. Select a damper that is specifically designed for the intended application. Consider dampers with features such as insulated blades, tight seals, and low leakage rates. The damper should be properly sized to provide adequate airflow for the generator's cooling requirements. Consult with the generator manufacturer to determine the appropriate airflow rate. The damper's actuation mechanism should be reliable and responsive. Consider dampers with electric or pneumatic actuators that can be easily integrated into the control system. The interlock system should be designed to prevent the generator from operating if the damper is not in the correct position. This can be achieved using limit switches or position sensors. The interlock system should also be designed to prevent the damper from closing if the generator is running. The control system should be designed to monitor the damper's position and status. The control system should also be able to automatically adjust the damper's position based on the generator's operating conditions. When designing the ventilation system, consider the following factors. The ventilation system should provide adequate airflow to remove heat and moisture from the generator room. The ventilation system should also be designed to prevent the accumulation of condensation. The ventilation system should be equipped with filters to remove dust and other contaminants from the air. Regular maintenance and testing of the damper system, interlock system, and ventilation system are essential to ensure their reliable operation. Develop a maintenance schedule that includes regular inspections, lubrication, and testing of all components. Keep detailed records of all maintenance and testing activities. Train personnel on the proper operation and maintenance of the damper system, interlock system, and ventilation system. In addition to these technical considerations, it is also important to consider the regulatory requirements that may apply to the generator installation. Consult with local authorities and building officials to ensure that the installation complies with all applicable codes and standards. The National Fire Protection Association NFPA 110 standard for emergency and standby power systems provides guidance on the installation and maintenance of emergency power systems, including generators. The American Society of Heating, Refrigerating and Air Conditioning Engineers ASHRAE provides guidance on the design and operation of ventilation systems. The National Electrical Code NEC provides guidance on the electrical installation of generators and associated equipment. By carefully considering these factors and implementing appropriate design, installation, and maintenance practices, you can ensure the reliable operation of the generator and the safety of the facility. Remember that redundancy and fail-safe mechanisms are key to a reliable system. If a motorized damper is chosen, ensure it has a manual override in case of motor failure. Consider a backup power source for the damper motor separate from the generator's main output, so a failure in the generator's primary system doesn't disable the damper. Explore using a combination of solutions. For example, using manually adjustable dampers for seasonal adjustments combined with a smaller, continuously running ventilation fan to prevent condensation. Document everything thoroughly. Maintain detailed records of the system's design, installation, testing, and maintenance. This will be invaluable for troubleshooting and future modifications. If possible, install sensors to monitor temperature, humidity, and airflow within the generator room. These sensors can provide early warning of potential problems. Consider using a programmable logic controller PLC to manage the damper, generator interlock, and ventilation system. A PLC can provide more sophisticated control and monitoring capabilities. Ensure that the generator room is adequately insulated to minimize heat loss during the winter. Insulation can reduce the need for heating and minimize the risk of condensation. Consider the potential for noise generated by the generator and ventilation system. Take measures to minimize noise pollution, such as installing sound attenuators. Regularly inspect the generator room for signs of water leaks or other damage. Address any problems promptly to prevent further damage. Ensure that the generator room is properly secured to prevent unauthorized access. The selection and implementation of specific solutions should be based on a thorough evaluation of the specific site conditions, generator requirements, and regulatory requirements. Also remember to coordinate closely with mechanical engineers, electrical engineers, and other professionals to ensure a well-integrated and reliable system. When designing the generator room and its associated systems, consider future expansion or modifications. Design this system to be flexible and adaptable to changing needs. Regularly review the generator room design and maintenance procedures to ensure they are still appropriate for the current operating conditions. As technology advances, consider incorporating new technologies and best practices into the generator room design and operation. Ensure that all equipment installed in the generator room is properly grounded to prevent electrical hazards. Provide adequate lighting in the generator room to facilitate maintenance and inspection activities. Install fire suppression equipment in the generator room to protect against fire hazards. The generator room should be designed to be easily accessible for maintenance and repair activities. Ensure that there is adequate space around the generator and other equipment for technicians to work safely. The generator room should be located in an area that is protected from flooding and other natural disasters. Consider the potential for fuel spills and other environmental hazards. Implement measures to contain and clean up any spills. Ensure that the generator is properly sized to meet the facility's power requirements. Oversizing the generator can lead to inefficiencies and increased costs. Consult with a qualified engineer to determine the appropriate generator size. Consider the potential for voltage fluctuations and other power quality issues. Install power conditioning equipment to protect sensitive electronic equipment. Regularly test the generator under a load to ensure it is capable of meeting the facility's power requirements. The load testing should be conducted under realistic operating conditions. Ensure that the generator is properly maintained in accordance with the manufacturer's recommendations. The maintenance should include regular oil changes, filter replacements, and inspections. Keep a supply of spare parts on hand to minimize downtime in the event of a generator failure. Train personnel on how to start and stop the generator and how to respond to emergency situations. Post emergency contact information in a prominent location in the generator room. Develop a written emergency plan that outlines the steps to be taken in the event of a power outage or other emergency. The emergency plan should be regularly reviewed and updated. Conduct regular drills to ensure that personnel are familiar with the emergency plan. By following these guidelines, you can help to ensure that the generator operates reliably and safely and that the facility is protected from power outages.